Good day, ladies and gentlemen. This is Banner's Online Maths. Let's see the problem we have on the board. The question says, if y is equals to sine inverse of x, we are asked to show that 1 minus x squared all in brackets multiplied by y prime prime minus xy prime equals 0. This is one of the problems in derivative. Okay, let's see what to do. Solution. Given that y equals to sine inverse of x, let's call this equation 1. As a matter of fact, of course, here we have to show that this equation is equal to 0. But for us to do that, we need to find the first derivative of y, that's y prime, and also find the second derivative of y, that's y prime prime. So from here, we have to differentiate y with respect to x. If we differentiate y with respect to x, that will give us dy dx. So that will give us our y prime, that's y prime, which is something as dy dx, will be equals to, if we differentiate sine inverse of x, we are going to have 1 all upon square root of 1 minus x squared. Let's call this equation 2. But the question now is, how come the derivative of y is 1 all upon square root of 1 minus x squared? How come? Let me explain. Suppose, of course, let's solve this in a rough. Suppose we have that y is equals to sine inverse of x. Now, what is x? From here, we now make x the subject of the formula. If we make x the subject of the formula, this is going to give us sine y equals to x. Of course, let's call this equation I. Now, we're going to, this is an implicit form of, it's an implicit function because we're not having a function of x and y. So we're going to differentiate implicitly. As a matter of fact, if we differentiate this function with respect to x, knowing fully well that what we are having here is y, so we are going to assume that it is x. So we're going to differentiate normal. And after differentiating, we multiply this by the differential coefficient, which is y prime, or dy dx. So if we differentiate this is going to give us, of course, this is going to give us, differentiate sine y, we're going to have cos y. Now times, why are we multiplying by the differential coefficient? Because this is not x, it is y. So we are differentiating implicitly. So times dy dx. Which is equals to differentiate x, we have 1. So our target here is to make dy dx the subject of the formula. If we do that, we divide both sides by cos y. Dividing both sides, dividing both sides by cos y. So we're going to have this to be cos y times dy dx, which is equals to 1. Divide the left hand side by what? Cos y. Divide the right hand side by cos y. So this will cancel that. Left here becomes that our dy dx will be equals to 1 over cos y. But from the trig identity, okay, let's do that here. from trig identity. We are told that cos squared y plus sin squared y is equal to 1. If this happens, we now have this to be that cos squared y is equals to 1 minus sin squared y. So our target is to make cos y the subject of the formula. If we do that, that's going to give us cos y, which is equals to square root. Remember, there is power here. Once power crosses equality sign, it changes to roots. So if the power crosses, that becomes square root of 1 minus sin squared y. So of course, we come from here. Let's call this equation II. Recall from equation II, that is this equation. Remember, this is what we are solving. What I'm doing here is to show you how the derivative of sin squared x becomes 1 all upon square root of 1 minus x squared. So this is mainly our rough work, trying to show you how the derivative of sine inverse of x becomes 1 all upon square root of minus x. Okay, now from equation II, which is this, so we now have that dy dx would be equals to 1 all upon, instead of cos y, our cos y had been gotten to be square root of 1 minus sin squared y. But from equation, of course, this is the same thing as dy dx is equals to 1 all upon square root of 1 minus sin squared y is the same thing as sin y all squared. Take note, sin squared y is the same thing as sin y all squared. Do we know y? Yes. What is y? From equation I, our sin y is equals to what? X. So from equation equation I, which says that sin y is equal to x. Therefore, we now substitute for sin y inside here. So we now have that our dy dx is equals to 1 all upon 1 square root of 1 minus, instead of sin y, we have x. Remember, it's squared, we square it. So that is why, of course, this is the same thing as y prime. So that is why the derivative of sine inverse of x becomes this.